Hey guys, welcome back to my YouTube channel. Myself Impana, studying in Sri Venkateshwara College of Engineering. Today I'm going to talk about Introduction to Python. My topic is defining and calling functions, explaining how to define and call functions in Python, including function names, parameters, and return values. The four steps to defining a function in Python are the following. Use the keyword def to declare the function and follow this up to the function name. Add parameters to the function. They should be within the parenthesis of the function. End your line with colon. Introduction. Defining and calling functions in Python. Functions are reusable blocks of code. They help in organizing and modularizing code. Defining functions. Use the def keyword to define a function. Function name should be descriptive and follow naming conventions. Parameters can be included inside parentheses after the function name. Function syntax. Function definition starts with def keyword followed by a function name and parenthesis. Indentation is important to define the body of the function. Function body contains statement to be executed when the function is called. Returning values. Use the return keyword to specify value to be returned by the function. Functions can return multiple values using tuples. If no return statement is provided, the function returns none by default. The result of the function can be given back to the calling functions. Return statement is used to return a value to the calling function. Calling functions. To call a function, use the function name followed by parenthesis. Arguments can be passed inside the parenthesis if the function expects parameters. The function is executed when it is called. Function parameters. Parameters are variables used to pass values into a function. Parameters can have default values, making them optional when calling the function. Multiple parameters can be separated by commas. Positional arguments. Positional arguments are passed on their position in the function cell. The order of arguments matters in positional arguments. The number of arguments passed must match the number of parameters defined. A list of argument values in a function cell is called as positional arguments. With positional parameters and positional arguments, parameters get their values based on the order of the values sent. Keyword arguments. Keyword arguments are passed using the parameter name and value. The order of keyword arguments does not matter. The function call becomes more readable and less error prone. Keyword argument or named argument. When we call a function with some values, these values get assigned to the arguments according to their position. Python allows function to be called using keyword arguments. When we call functions in this way, the order or position of the arguments can be changed. Arbitrary argumentist. Functions can accept a variable number of arguments using before the parameter name. The arguments are treated as tuple inside the function. Calling functions within functions. Functions can call other functions. This allows for code reuse and better organization. The output of one function can be passed as an argument to another. Recursion. A function can call itself, which is called recursion. Recursion is useful for solving problems that can be divided into smaller subproblems. It requires a base case to stop the recursive calls. Function documentation. Document functions using docstrings. Docstrings are enclosed in triple quotes and provide a description of the function. They are accessible using the help function. Function scope. Variables defined inside a function have local scope. They are only accessible within the function. Global variables can be accessed within function, but modification requires the global keyword. Conclusion. Functions are essential for the code organization and reusability. Defining and calling function in Python is simple and inno- initiative. Understanding functions is crucial for becoming proficient in Python programming. Programming is the process of taking an algorithm and encoding it into a notation so that it can be executed by a computer. Although many programming languages and many different types of computer exist, the important first step is to need to have the solution. Without an algorithm, there can be no program. Thank you.